So topic wise, we'll try Excel logo का add करो. So एक ये कि सारे टाइप के
क्या हुआ?
हेलो आवाज आ रही है?
यस सर।
चले. अच्छा, starting with the first thing, ठीक है, moles का you can normally जो recent past papers है, you're not getting a moles question, so that might come as a surprise because last 2-3 years, ठीक है, there's not been a lot of moles questions in at least paper 2. So previously you have had big questions, 14-15 marks. So chances है कि maybe you might end up with one big question. So we're going to start off with the big ones first, ठीक है, एक दो titration के questions कर लेते हैं. Yeah, for example, we can try and do this question. As a titration का एक question. Start कर लेते हैं. Start with the first thing, ठीक है, just need a calculator, just hold on 1 second. ठीक है, calculator. As I started with this question, ठीक है, we'll just do a couple of titration questions. You might get a big questions. Paper 3 में तो वैसे ही आना ही है. You've got a question about ammonium salts. Anyway, just has react kariye. What is going to be formed? Whenever an ammonium salt reacts with a base, it is going to form salt, water, and ammonia. The ammonium ions are going to lose H+1 ions. Okay, make sure you remember your equations. Most questions, they don't very often give you equations. So a lot of times you would have to make the equations yourself. So starting with the first thing, which is ammonia gas gets produced, OH ions, they turn into water. And your salt is going to be produced, which is going to be Na2SO4. And you're going to try and balance this. So there's two N's over here, so there's going to be two NH3s. There are OH कहते हैं that 2OH, so there'll be two water molecules getting produced. ठीक है. The rest of the equation kind of looks balanced. As a सारा questions यही पे, so we can try and do the entire question here. He says that the fertilizer, this ammonium salt is part of a fertilizer. That's the first thing. And you have to find the impurity of this. The percentage purity, sorry. Okay, how much of the fertilizer? And he's given you the mass of the fertilizer, which is 5 gram. So it's a 5 gram fertilizer. Yeah, actually 5 gram. Yeah. The fertilizer is what's 5 gram. As I said, it's a 5 gram fertilizer. And it's got ammonium sulfate in it. So we have no idea how much ammonium sulfate we've got. It is reacted or warmed with an excess of NaOH. So make sure it's in excess. So iske moles निकालो कितना NaOH डाला? How much NaOH was added? What is 50 cm cubed? I'm going to find moles over here. Concentration times volume.
0.1 moles.
कितने आ रहे?
So 0.1.
So we're getting 0.1 moles. ठीक है, that's the moles. Like remember, that's in excess. That means not all of it is reacting. When all the ammonia had been driven off, the solution was cooled and the remaining NaOH. So there is some remaining NaOH. What happens to the remaining NaOH? The remaining NaOH was titrated with HCl. So this remaining NaOH, बच गया. ठीक है, this NaOH he is asking for an equation where the HCl, so it's going to form NaCl plus. H2O 1:1. So how much the remaining NaOH was titrated with HCl? So this is the concentration and the volume of HCl. So इसके moles कितने बन रहे? 31.2 divided by 1000.
Says 0.0312.
So 0.0312 moles. So that's all the information that you have. And you have to find the percentage purity. So you took 5 grams impure, added it to excess NaOH. Some of the NaOH was left. We don't know how much added reacted with the HCl. So we know how much NaOH was left. Okay, it's 1:1. So NaOH ke moles kya hoge? It's going to be 0.0312 moles. So we can now find out how much NaOH actually took part in the reaction. If you added 0.1 or piche end mein there's still 0.0312 left. So how much actually took part in the reaction? You subtract the two. You added 0.1, 0.0312 is still left at the end. So difference nikalo, what do you get?
Says 0.0688.
कितना 0.088? कितना? I didn't get it.
6.8.
That's a 688. So you're getting 0.0688. So you found out कि भाई 0.1 में से is 0.0688 that actually reacted. Now the other part is what is the moles of ammonium sulfate? Then that's 2:1. So what is the half of this? That will be 0.0312 again. Half of that will be 2:1. Okay, so it's going to be half of that, right?
Say 344.
4:4 है? हाँ
Yes,
ठीक है.
sir.
अच्छा नहीं मैं नीचे से sorry. 344. And now you can find the mass of this. Mass is moles multiplied by MR. Achha, make sure okay, when you're doing the working, to uske na exactly tell them what you're doing. ठीक है, because you don't want to lose marks. Okay, अगर calculator पे you lose marks, make sure your working is as clearly as possible and write everything simple. Require everything to 3 significant figures. So, what is the mass? The MR kya is ki MR? That's NH4 is 18. 18 times 2, that's 36. 36 plus ये क्या होता है? 96. What do you get?
Sir, 136.
136. 36 plus 96. 132 होगा. Check कर लो, what's the MR?
Yes, sir, it's 132.
And to be precise, it's 132.1. Well, you have to always make sure you're using the most accurate value. Sulfur is 32.1. So kya answer hai? What's the mass?
4.54.
So that is 4.54 grams. So you're supposed to find the percentage purity at the end. So you have the 5 gram fertilizer. So what's the percentage purity? That's out of the 5 grams, आपका जो fertilizer था, that was 4.54 grams into 100. So what do you get?
So 90.9%.
90.8.
So 90 point round off 2, 3 significant figures, 9%, right? So that's it. वो से parts के अंदर he's divided the whole question, but that's the whole question here. ठीक है. So the excess वाले, ठीक है, we'll do a bit more of these excess questions. So next one. This one is about water of crystallization. So water of crystallization के ऊपर, you're supposed to figure out the X in you're supposed to figure out the X in Na2CO3. Now, washing soda is hydrated sodium carbonate. A student wished to determine the value of X by carrying out a titration with the following results. So, one second. The washing soda crystal is this. I mean, he's added 5 point. He's asking you to write an equation. So it's the washing soda crystal Na2CO3, and it reacts with HCl. क्या होगा? Carbonate plus acid, salt, water, and carbon dioxide. You can balance it with HCl. So the other part is so calculate the amount of moles of HCl that reacted. So I mean, he's reacting the crystals with HCl. अच्छा लेकिन यहाँ पे ना there's a यहाँ पे dilution हुई है, ठीक है? Let me just go through this. First thing he did was he added these crystals. कितने grams था? He took 5.13 grams of these crystals and he added it and made it into a 250 cm cube solution. So this entire crystals were added and you had a 250 cm cube solution now of Na2CO3. Now the other part is 25 cm cube of the solution reacted exactly, now not the whole solution, 25 cm cube of this. So he further took just a 25 cm cube sample of the same Na2CO3 and he reacted it with HCl. Or वहां से ना the HCl volume and concentration is given, so you can find the moles of HCl. So how many moles do we have?
So it's 3.58 into 10 raised to power minus 3.
So we have 3.58 times 10 power minus 3 moles of HCl. So Na2CO3 के moles क्या होंगे? That's going to be 2:1, right? So that will be half of that. So यहाँ पे how many moles do we have? What is half of that?
So 1.79 into 10 raised to power minus 3.
So that's the moles of Na2CO3 in the 25 cm cube over here. Next, he's going to ask you, what is the moles in 250 cm cube? So in 25 cm cube of Na2CO3, you had this much. So 250 में क्या होगा? According to the ratio, that's going to be 10 times more. So this will be how much? 1.79. You clear 10 power minus 2 moles होंगे. Is that clear?
Yes, yes.
So we did this part as well, 250 ke andar. Now the last part, which is that hence calculate the mass of Na2CO3. So you found the moles of Na2CO3, so you can find out the mass. What we have found out is that Na2CO3 ke jo moles are, that's 1.79 times 10 power minus 2. So iski mass nikalo. What is the mass that you're getting for this? और इसको मैं इधर पढ़ा करके लिख देता हूँ. इस पूरे क्रिस्टल की ना जो mass है, the entire mass, that is 5.13 grams. The moles of Na2CO3 that we found out was 1.79 times 10 to the power minus 2. So इस part की mass निकालो. How much multiplied by the MR? I think the MR is कितना होगा? 106. 16 into 3, 48 plus 12, that's 60. 60 plus 2 to the 23, so that's, I think, 106. So the MR is, so what is the mass that you're getting?
Say 1.90.
इसका मतलब इसकी जो mass है that's 1 point. Now out of this entire crystal, 5.13, 1.90 is this part. So what is the mass of water then? 5.13 में से minus 1.90.
Say 3.23.
So you're getting 3.23 grams. So you had 1.90 grams of sodium carbonate in the crystal, and you had 3.23 grams of of water in it. So the next part, how do you find X? Because X is a mole ratio, right? So we have the moles of this, and now we can find the moles of water as well. So water के moles कितना होंगे? That's you know the mass of water divided by 18. So how many moles do you get?
Say 0.18.
So 0.18. I mean, इसको वैसे ना we can round this off to 1.8. So we can round this part off to. So we're getting 0.18 for this. 106 पे हटा देता हूँ. So I got these moles and I got these moles for this. So what is the mole ratio? I think that's 1:10. क्या ratio आ रहा है? That's 1:10.
सॉरी अगर 1:1 है सोडियम कार्बोनेट और वाटर तो आपने इसको 1.8 क्यों किया?
1.79 था.
अच्छा सही से आपने उसको राउंड अप किया है, ठीक है.
वो 18 आ रहा था, मैंने कहा just make it 1.8, right? So this is what 1:10. 1.8 ratio 0.18. Sorry, 1.8 times 10 to the minus 2. इसको वैसे expand करके भी लिख लो. It's going to be 0.018 moles of this. और इसके moles कितने हैं? That's 0.18 moles. How do you find the whole number ratio? That's divided by the smallest, which is you're going to divide both by 0.018. So when you do that, it's going to be 1:10. Is this clear?
Yes sir.
Yes.
That's the next one. So there's this question again. He says a sample of थोड़ा सा मुश्किल कर लेते हैं, बाकी टाइप्स भी करनी है. Let's try this one. अच्छा, तो इसके अंदर थोड़े से ज्यादा steps होंगे. Starting with the first thing that you have to find the purity of the sample of sodium nitrate. So इसकी ना you have to find the purity of this thing. The compound is heated in NaOH, where Devada's alloy which contains aluminium, so it's heated with NaOH. Ammonia is boiled off and then dissolved in acid. So the ammonia gas is produced, and then it's further dissolved in acid, and it's dissolved in excess of sulfuric acid. तो वो excess में. The unreacted sulfuric acid is then determined by back titration with NaOH. So जो unreacted है ना, excess में, the leftover, that is then again reacted with NaOH. And the overall क्या हो रहा है? You took NaNO3, ammonia gas got produced. Ammonia gas was dissolved in sulfuric acid. It was in excess. Some of the sulfuric acid was unreacted. So that unreacted sulfuric acid was then added to NaOH. ठीक है. And अब data यहाँ पे given है. How much of the impure NaNO3 did you take? You took 1.64 grams. But impure, ठीक है. So that means that's not NaNO3. अच्छा, the NH3 produced was dissolved in कितने mole sulfuric acid है? How much is this? So what amount of sulfuric acid was it dissolved in? 25 times 1 divide by 1000. कितने moles
So
बन रहे हैं?
0.025.
025 25. So 025.
Sir, 0.25.
But remember, that's in excess. अच्छा फिर when all the NH3 had dissolved, the resulting solution, वो जो excess H2SO4, was neutralized by NaOH. So how many moles of NaOH were added?
So 0.0324.
That's a 0.0324.
0324.
ऐसे यहाँ तक कहानी पहुंची है, ठीक है? So basically you added 1.64 grams impure. Ammonia got produced, you added it in excess sulfuric acid, which was 0.025 moles. The excess remaining H2SO4 was titrated with NaOH, and the moles of NaOH are given, that's 0.0324 moles. Ab, based on that, you have to basically figure out the purity. So step by step, most of the questions. So the first thing he asked was that what is the amount of sulfuric acid that's left? There's 2:1. So what is the half of this?
So 0.0162.
That's a 0.0162 moles, 2:1. That's the amount of sulfuric acid that is left at the end. पिछले part में add कितने किए थे? He added 0.025 and there's 0.0162 that's still left at the end. So how much actually took part of the reaction with ammonia? So 0.025 were added. 0.0162 is still left. तो कितने react कर रहे हैं यहाँ पे? What is 0.025 minus 0.0162?
So 0.0088.
0 एक 0.
So 20.
So 0.0. ठीक है, तो 0.25 moles were added. 0.0162 moles are still left at the end. So इसका मतलब 0.0088 moles reacted. It's 1:2, though the amount of ammonia that reacted with it would be double that, right? तो क्या होगा इसका double? 0.0088. What's the double of that?
So 0.0176.
And all of that ammonia got produced in the first reaction, 0.017. Remember, don't compare the moles ratio of one equation with the other one. All the ammonia that got produced in the first reaction was used in the second reaction. So will be 0.0176 hoga. So the amount of sodium nitrate, it's the same ratio. So that's going to be exactly the same. Baki reh gaya, you just have to find the mass now. What is mass? Moles multiplied by MR. So that's going to be 0.0176. And multiply that by the MR. Kya hota hai? That's NO3. That's 16 into 3. That's 48, 62, 85.
Yes, sir, 85.
कितनी mass है?
So 1.50.
So you're getting 1.50. And then you have to find the percentage purity, which is going to be 1.50 is out of 1.64. So what do you get?
So 91.4%.
So you're getting 91.4%. अच्छा, question. If you ever get this question, recently you're not getting a lot of most questions. Like if you get keep track of what's happening, okay? So, you clear?
सर हम लोग दोनों इक्वेशंस को शुरू में लाइक ऐड कर सकते थे ताकि एक ही इक्वेशन बन जाती जो पहली दो है।
अगर हम दोनों को ऐड कर देते हैं ये उसमें फिर बहुत कंफ्यूजन हो जाती क्योंकि H2SO4 जो है ना वो तो कम्प्लीटली रिएक्ट ही नहीं कर रहा। प्रॉब्लम तो क्या होता है कि मे बी H2SO4 शायद पिछले रिएक्शन में ऐड कर रहा होता, मतलब चांसेस है ना कि वो रिएक्ट कर रहा होता अगर पिछली इक्वेशन में। फिर मसला होता आपके मोल्स यहाँ पे डिफरेंट हो जाते हैं, वो फिर इसके साथ जो रेशियो बन रहा था और जो चीज हो रही थी वो फिर ज्यादा कंफ्यूजिंग हो जाता।
ठीक
इज
है
दैट
सर।
क्लियर?
Yes, sir.
अच्छा खैर दैट्स वन पार्ट, ठीक है। एक लेट्स डू वन क्वेश्चन क्विकली फॉर empirical formula कैसे निकालते हैं अब other types, ठीक है। we did two titration, अभी we'll do some redox titration questions as well। किस तरह निकालते हैं empirical formula? you find the moles divided by the MR। ज्यादातर लोग जो इजी चीज होती है वो गलत कर देते हैं। I think fluorine is 19। कितने moles आ रहे हैं? what's the first one? what are the moles that you're getting?
सर 1.48।
ठीक है 1.48। what about this one? either 1.5। what's this?
सर इसके भी 1.48 है।
and this is what? ये भी 1.48 है शायद, ठीक है।
ये सर 1.48 है।
तो सारों में एक ही रेशो आ गया। that's 1:1:1। you got carbon 1 H1 Cl1 F1, that's the so the MR that's given is what? 135। remember molecular formula is n times the empirical formula। find it's multiples हो सकते हैं ना the ratio, this is the simplest ratio। so find out ये क्या बन रहा है? that's 12 plus 113, 13 plus 30 5.5 plus 19 कितना हो गया?
सर 67.5 आ रहा है।
so n की क्या वैल्यू होगी? that's going to be, I mean this is 60, डबल होगा फिर। so मतलब your actual formula is going to be C2H2Cl2 and F2। is that clear?
यस सर।
Yes.
अच्छा बस empirical formulas में just make sure कि if you sometimes these like be questions ना just one second अच्छा थोड़ा सा empirical formula का ना एक मुश्किल क्वेश्चन मैं करा देता हूँ, ठीक है। रिवर्स में sometimes they might ask you something in reverse, ठीक है। एक वैसे था empirical formula का अच्छा रिवर्स का ना मैं खुद ही बना देता हूँ एक ना, एक करते हैं फॉरवर्ड डायरेक्शन में फिर उसको बैकवर्ड डायरेक्शन में, ठीक है। एक क्विकली से ना एक क्वेश्चन रिवर्स वाला, यू नॉट यूज्ड टू रिवर्स क्वेश्चंस। so for example if I have MgCl2, ठीक है। can you tell me the percentage composition of this thing? It's this is Mg is 24.3, Cl is 35.5 times 2। मुझे जरा कैलकुलेटर पे क्विकली बताओ कि what's the percentage composition of Mg and what's the percentage composition of Cl? मतलब 24.3 divided by the total, जो भी टोटल है।
सर mg का आ रहा है 25.5।
अच्छा कितना आ रहा है? 25.5%। और उसका माइनस कर दो, that's going to be what? 74.5
37.3.
नहीं, कैसे हो सकता है?
सर उसका नहीं डिवाइड करना उसके ऊपर टोटल के ऊपर.
CL तो 2 है ना, तो दोनों को इकट्ठा लोगे ना. CL की कॉम्पोजिशन क्या होगी? जैसे ये CL है ना, मिला के लोगे ना CL की कॉम्पोजिशन. इज दैट क्लियर? अच्छा खैर, अब
Yes,
इस
sir.
क्वेश्चन, अच्छा इस क्वेश्चन में आ जाते हैं. अच्छा, तो इग्नोर कि मैंने ये काम करवाया था आपसे. लेट्स से आई हैव गॉट अ फार्मूला व्हिच इज दैट mg है और x2 है, और उससे कहा हुआ है कि इसकी जो वो है ना परसेंटेज कॉम्पोजिशन, दैट्स 25.5% एंड दिस इज 74.5%. और वो कह रहा है कि इसकी ना वो निकालो, निकाले इसका MR, sorry, AR of x. Find out or identify x. What is x? ठीक है, रिवर्स टाइप ऑफ क्वेश्चन है. ठीक है, तो यू गिवन द परसेंटेज कॉम्पोजिशन, slightly tricky है क्योंकि how would you solve this? ठीक है, if they give you the percentage composition, how do you reach the AR of x? तो आप steps वही करोगे, empirical form. How do you find the empirical formula? You already know what the empirical formula is. It's 1:2, right? How do you find the empirical formula? क्या होता है? Divide by the AR. So divide by the AR of mg. X का आपको नहीं पता, so divide by the AR of x. You don't know what x is, so that's x. But you also, to AR क्या, the unknown is x. Now you already know that this ratio is going to come out to be 1:2. The formula is right in front of you. You know it's 1:2. You're going to cross multiply it. इस तरह का question आया था. No one was able to do this. They gave you the person and they were actually telling you to find the AR of x. अब आसान है. You know the ratio is 1:2, right? Cross multiply. So it's going to be 25.5 divided by 24.3. That's times 2 is equal to 74.5 over x into 1. इसको सॉल्व करो, देखो x, does it come out to be 35.5? ये किसी ने सॉल्व किया?
Yes, sir. 35.5 आ रहा है.
ठीक है, लेकिन आइडिया क्लियर है कि it's you're actually doing exactly the same way, but it's just the reverse. Okay, you didn't know the starting point, you knew the answer, what the answer is going to be. The empirical formula का reverse type of question, where the ratio is already known, you just won't know what the AR is. ठीक है, so you repeat the exact same steps, and that will leave you with the unknown, that's x, and you'll solve that x. अच्छा, next one, let's do वो टाइट्रेशन के कर लिए थे. redox टाइट्रेशन पे आते हैं अभी. ठीक है, we'll come back to redox. ये वाले कर लेते हैं. एक सेकेंड. combustion analysis. ठीक है, remember this कि किधर गया? अच्छा, MCQs को छोड़ दो. अच्छा सॉरी, मैंने MCQs को. अच्छा, combustion analysis. ठीक है, remember ये भी उनका favorite question है paper 2 का. You've got this alcohol. ठीक है, remember combustion analysis when you burn something and it produces carbon dioxide and water. Temperature is kind of important. That will tell you which substances are gases. Gases के अंदर there's a rule that mole ratio of a gas and the volume ratio of a gas are exactly the same. The mole ratio equals volume ratio for gases. तो अब यहाँ पे वो क्या कह रहा है कि if you read the question carefully, saying that there was a 20 cm cube gaseous sample of CxH by O, तो ये 20 cm cube है. It is reacted with कितना oxygen? 200 cm cube of excess oxygen. But remember, this is in excess. The final volume measured under the same conditions as the gaseous sample was 250. So final volume जो है ना, that happens to be 250 cm cube. अब इस final volume में क्या क्या होगा? ये बताओ क्या होगा इस final volume में?
फिर O2 होगा, वाटर वेपर होगा और कार्बन डाइऑक्साइड.
ठीक है, क्योंकि टेम्परेचर 120 है तो वाटर वेपर would also be in vapor form. ठीक है, so it's going to have the products carbon dioxide, water, and it will have the unreacted oxygen. वो भी बीच में होगी. It will have unreacted oxygen. So then he says that under these conditions, all the water present is vaporized. When he removes the water vapor from the gaseous mixture, the volume decreases to 170. The water remove किया तो 170 हो गया. तो इसका मतलब water कितना था? That was 80 cm cube. Right? Is this clear? कि 80 होगा ना water. क्योंकि water remove किया 250 से it became all of a sudden it became 170. Then when he reacted the mixture with alkali to absorb the carbon dioxide, the volume decreases to 110. तो 170 से कम हो गया 110 हो गया. कार्बन डाइऑक्साइड रिमूव किया. So carbon dioxide must be what? 60 cm cube. तो एंड में क्या बचा? 110. That's your unreacted O2. Is this clear?
Yes, sir.
तो 200 में से पीछे रह गए 110 is left unreacted. So that means how much is reacting? 90, right? क्योंकि जब 250 बना था उसका 110 oxygen is still left. So that means out of the 200 that you added initially, there is 110 still left at the end. तो फिर अगला पार्ट क्या है? कार्बन डाइऑक्साइड कितना है? That's 60. cm cube and water कितना है? That's 80 centimeter cube. So find out what X and Y are. So gases a mole ratio, volume ratio is exactly the same. So what is the volume ratio? तो mole ratio क्या होगा? 20, 90, 60 and 80. So that's 1, 4.5, 3 and 4. ये ratio बन रहा है ना? So that means X has a value of 3, while Y by 2 has a value of 4. If we solve for Y, Y would come out to be equal to 8. So the formula of this hydrocarbon would come out to be C3H8O. ठीक है, इस पूरी एक्सरसाइज से we were able to figure out 20 reacts with 90, produces 60 and forms 80 of this. Mole ratio wise, it's 1 ratio 4. मतलब 20-90 का ratio क्या होता है? That's 1 ratio 4.5. Ratio 3 ratio 4. And you're able to figure out the value of X, you're able to figure out the value of Y by 2. और end में आपके पास आंसर आ गया. Is this part clear? ये clear?
Yes.
So एक और commercial analysis. ये वाला कर लेते हैं. Here you're being asked to figure out or write the equation, which is तो क्या होगा? You have to remember this equation. It's x CO2 and y by 2 H2O. Now something similar is happening. Okay, there's a 10 cm cube mixture of, sorry, A was mixed with 50 cm cube oxygen. So इसके उठाया उसका 10 and he reacted it with 50 cm cube. And it was exploded. और फिर क्या 40 cm cube of gas remained at the end. So what is this? What is this 40 cm cube of gas that remains at the end? पहले तो temperature देखो ये किस temperature पे, at what temperature is he is doing it at room temperature. So जो end में 40 cm cube gas होगी, what is that? इसमें क्या क्या होगा? इसमें
All three, sir.
Huh?
O2, CO2, H2O. All three, sir.
which three?
O2, CO2, H2O.
It won't have H2O because it's at room temperature. H2 is not a gas. ठीक है? So 40 cm cube gas remained. So it's CO2 and the unreacted oxygen, right? Is that clear? CO2 and the unreacted oxygen. And then it's shaken with potassium hydroxide, which will dissolve the carbon dioxide. The volume decreases to 30. So that means the volume decreases by 10. So that means carbon dioxide has a volume of 10 cm cube and the remaining 30 is basically the unreacted oxygen. So out of this 50, 30 is still unreacted at the end. So only 20 cm cube took part in the reaction. And how much carbon dioxide got produced? 10 cm cube. So again, 10 cm cube was exploded with 50 cm cube and it ended up producing 40 cm cube of gas. So वो products होंगे, that's carbon dioxide. Water is not going to be a gas, so the 40 cm cube that's produced, that's carbon dioxide and the unreacted oxygen. Out of that 40 cm cube, when he shook it with KOH, the volume decreases to 30. So that means 10 cm cube of carbon dioxide is gone. So the volume of carbon dioxide is 10 cm cube. And whatever is left, that's your unreacted oxygen. So out of this 50, there's 30 still left. So that means 20 is reacting. So you found out, क्या ratio बना है? 10 ratio 20 ratio 10. So the ratio that you're getting in this case is 1 ratio, इसका क्या है? 2 ratio 1, right? So that means X has a value of 1. And this entire thing, X plus Y by 4 has a value of 2. And you can solve for Y then, because you know that X is 1. So 1 plus Y by 4 is equal to 2. 1 ko to leke jao, it's going to become 1. Y would be equal to 4. So the answer is X is 1 and C1H4. You clear?
Yes, sir.
This was a redox. अच्छा वो क्वेश्चन मुझे मिल गया था एक सेकंड, इलेक्ट्रोटॉमिक मास, जस्ट अ सेकंड. अच्छा, but let's do one redox titration as well. अच्छा, the only difference between a redox titration and a normal titration is that I mean it's going to be solved in exactly the same way, except for one difference, which is that sometimes they might not give you a balanced equation. Let's say ये question के अंदर ना the equation is not balanced. And that kind of makes the question difficult because you would have to balance the equation first. If it's not a balanced equation, your ratios are not going to work. So redox में बस ये फर्क है उसके अंदर इसमें कि they might ask you to balance an equation. Now redox equations are balanced differently. So let's assume that this equation is not balanced. So how do you balance this? So you'll use oxidation states. What is the oxidation state of chromium over here? यहाँ पे क्या है?
So +6.
ठीक है +6 है. तो यहाँ पे it's +3. What is the oxidation state of Fe? That's +2. यहाँ पे that's +3, so that's obvious. So who's gaining electrons, getting reduced? Chromium is the one that's getting reduced. Gains how many electrons? 3 electrons. And Fe is the one that's getting oxidized. Loses how many electrons? Loses 1 electrons. अच्छा फिर issue ये कि in the formula you've got 2 chromiums. So 1 chromium goes from +6 to +3. So 2 chromiums will actually be gaining 6 electrons. क्योंकि you've got 2 chromiums in the formula. तो ये तो वैसे ही 2 हो जाएगा, this thing. So the number of electrons lost and gained, they must be equal. So I would have to multiply this by, क्योंकि वहाँ पे the amount of electrons that are being gained, 1 chromium was gaining 3 electrons. You've got 2 chromiums in the formula, so that's gaining 6 electrons. So I would have to multiply this by 6. Iron would have to lose 6 electrons at all cost. So I would have to multiply it by 6. So iron को multiply कर दोगे 6 से. Now the equation is balanced at least electron wise. और जब वो balance हो जाए तो फिर the rest of the equation can be balanced easily. There's 7 oxygens, so there's going to be 7 water molecules. There's 14 H's, so there's going to be 14 H's over here. ठीक है, तो बस redox equation titration के अंदर the only difference is that they might ask you to balance the equation. तो ये बस practice कर लेना थोड़ी सी. अच्छा, so in this case it's already balanced. The rest of the question is exactly the same. अच्छा, question में क्या है कि there's a 5-gram sample of spathos. वो क्या है? FeCO3. So I'm assuming that FeCO3 से ना this Fe2 plus is coming from. वही है, वो percentage of iron to carbonate in spathos can be determined by. So I think the Fe2 plus is coming from there. कितना spathos है? That's 5 gram. That's probably impure. तो उसको से solution बना दिया. He turned it into a 250 cm3 solution. ठीक है, he turned it into a 250 cm3 solution. And then 25 cm3 of this solution was, so इसको titrate नहीं किया. He took a 25 cm3 solution of iron. So what he did initially was that he took spathos, which is FeCO3, made it into a 250 cm3 solution. And out of that 250, he took 25 cm3 and then reacted it with dichromate 6. So then Carlo, how much dichromate 6 was used? How many moles is this? वो उससे पहले पूछा कितने moles है?
So 5.46 times 10 power -4.
कितना 5 point?
46 times 10 power -4.
So the moles of Fe would be what? 1:6. So that's going to be 6 times more. So multiply this by 6. You'll get the moles of Fe. कितना आ रहा है?
So 3.276 times 10 power -3.
कितना 3.276?
3.276 times 10 power -3.
But remember that moles is in 25 cm cube. The original solution was 250 cm cube. So 25 में अगर इतने हैं, 250 में it's going to be 10 times more. So 250 में your moles will be multiplied by 10, right? और फिर last thing, so Fe के moles are वही exactly Fe is like one FeCO3 produces how many Fe ions? It's going to produce one Fe ion, right?
Yes, sir.
So the moles of Fe ions and the moles of FeCO3 are exactly the same. तो उसको MR से multiply कर लो, Fe क्या होता है? That's 55.8 plus 12. So you'll get the mass of FeCO3.
So 3.79 grams.
3.7 grams.
3.79 grams.
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 So you can find the percentage purity now. 3.79 out of 5 into 100, right? Is that clear?
Yes, sir. 75.8%.
Okay, that's 75 point.
75.8%.
You're getting 75.8%. So just remember redox titration, but the only difference is that you might be asked to balance the redox equation. Otherwise, the titration question is pretty much the same. अच्छा फिर this will be tricky. एक आध question कर लेते हैं. Let's try and do this one. This titanium 0.72 titanium का कोई figure out what is the symbol of titanium? Ti तो नहीं होता. कोई idea titanium?
47.9.
हाँ?
MR 47.9.
नहीं symbol क्या उसका?
Oh, symbol. TI.
हाँ sorry Ti ही है हाँ. अच्छा Ti is reacting how much? 0.72 grams with excess of chlorine. And you get a chloride A. And you have no idea what the formula is. So you get some chloride, you don't know what X is, you don't know what Y is, but the mass is given that's 2.85 grams. So based on this information alone, can you figure out the empirical formula of A? Ti or Cl ki alag mass, can you figure that out? Like what is the mass of Ti over here? That's given, that's 0.72 grams. So Cl kitna hoga? Yeah, that's going to be 2.13 grams. So they gave us the mass of titanium. So Cl is obviously the rest of it. And then you can get the 47.9 divided by MR. divide by MR. What do you get?
For titanium, it's 0.0150.
इसका क्या?
0.06.
Okay, that's 0 point. So the other part is 0.0. So what's the ratio? It's divided by the smallest 0.015. So it's going to be 1 ratio. 1 ratio 4, right?
Yes.
And based on that, you can figure out the equation. See ya. तो सर ठीक है, ये कल कंटिन्यू करते हैं, ठीक है?
Okay, sir.
एक डिफरेंट टॉपिक कल कर लेंगे, ठीक है? ओके एवरीवन,
Thank you.
ठीक है, अल्लाह हाफिज़.